Good morning and welcome to Algebra 1. Today we're going to go over the worksheet which was helping us to review for solving and graphing compound inequalities. So follow along and make sure that you got the answers you're hoping for. 1 through 5 ask you if a certain value falls into the solution set. So really here's what you had to do. For number 1, for example, it's asking about the number 13. It wants to know if it falls into x is greater than 5 and x is less than 10. That was the question. So does 13 fit the criteria of being both greater than 5 as well as less than 10? If it doesn't fall into that criteria, the answer is no. Well, 13 is definitely greater than 5. However, 13 is not less than 10. So the answer to number 1, does it fall into the solution set, is actually no, because it's not both greater than 5 and less than 10. The answer to number 1 is no. Number 2. Still looking at the number 13, the inequality is x is greater than 5 or x is less than 10. Well, we already just checked to see where 13 falls in relation to those two parts of the inequality. Again, yes, definitely greater than 5. Again, no, not less than 10. But this time the word was or. Or obviously means it doesn't have to be on both sides, one or the other. Because the answer was yes for the first option, the answer to number 2 is yes. 13 does qualify as a solution because it is greater than 5, whether or not it's less than 10. The words or versus and make a big difference. Number 3, thinking of the number 4, does it fit into x is greater than 0 and x is less than 7? Well, is the number 4 greater than 0? Obviously, yes, it is. Is the number 4 less than 7, though? Yes, it is. Because it is on both of these inequalities, it is a solution to the system of inequalities. Basically, it's, again, the intersection, a compound inequality made up of the two components together. Number 4, think of the number 5 and tell me if it is, well, this time they used a different notation system, but we've talked about this before. When you're looking at the notation where x is between two values, it's an intersection problem. It's an and problem. So is x between -3 and +6? Well, the number 5 falls less than 6, somewhere in there. And because it is within those two bounds, what's the answer? Yes. Yes, it is a solution. Number 5 asks us to think of the number 7, and it gives us the same compound inequality where we're looking for x values to be between -3 and +6. Where does 7 fall in relation to this inequality? Well, 7 is, of course, higher than 6, so it's somewhere over here. You can see that 7 is not falling within the bounds of -3 to +6. It is not a solution to this inequality. The answer is no. All right, so that was the first 5 questions, and for 6, 7, 8, and 9, we have to solve and graph. So let's get to that. Number 6, we have 2x minus 6 is less than -4, or 9 minus 3x is less than or equal to 3. All right. we have to solve both parts of this inequality, and then we can graph it. So let's take a look and see what happens. On this one, I have to add 6 to both sides. We add 6 because we're trying to isolate the variable x, and that term, the minus 6, well, it doesn't belong there. So we're getting rid of it using the inverse operation. We're adding instead. That cancels it out on the left side. 2x is less than negative 4 plus 6 is positive 2. Now I have to divide both sides by 2 to get the x by itself. See, that cancels out the 2's here. And on the right side, 2 divided by 2 is the number 1. Now I can go to the other side. I have a constant, number 9, a variable of negative 3x. On the other side, another constant. Again, I'm trying to get the variable term by itself, so I'm going to remove the 9. It was a positive 9, so I have to subtract 9 from both sides. So I have negative 3x is less than or equal to negative 6. All I have left to do is divide by the coefficient of x. This time it's negative, so be careful. I said that whenever you divide or multiply by a negative number, the inequality symbol is going to flip. Negative 6 over negative 3 is 2. Really, here's what's happening. When you multiply or divide an inequality by a negative number, you're creating an opposite. Negative is the opposite of positive. By making it an opposite of what it was, you have to reverse the inequality symbol, because what was less than is now greater than. That's what happens when you multiply or divide by a negative number. Okay, I've got my number line graph now. 1 and 2 are what we call anchor points. They anchor the graph. So I'm going to put 1 and 2 on my number line. I do not need any other numbers. The symbol next to the 1 was less than, so it's an open circle. Less than values lie on the left of the dot. On the other side, x is greater than or equal to. Because it could be equal to, it's a closed dot above the 2. Greater than values go to the right. So that is the solution numerically as well as graphically. Okay? Moving on to number 7. Number 7 said negative 6 is less than or equal to 2x plus 4, which is less than 8. I've given examples of this before. I did them in class and I've done them on video. So what we have to do here is solve for x as always. But remember that the x this time is in between 2 other values, in between 2 other inequality symbols. To get that x by itself, you have to carefully isolate that term. The first thing you want to do is remove the plus 4. Because again, it doesn't belong there if I want to get the x by itself. How do you remove plus 4? You subtract 4. But where? Well, over here certainly, but also on both sides of the inequality. If you're not doing it on both sides, it's not going to be in balance and it's not going to be right. Negative 6 minus 4 more is negative 10. Less than or equal to 2x. Less than 8 minus 4 is 4. We're almost done. All we have left to do is to divide by the coefficient of x. So that 2 I have to divide by, but where do I divide? Well, here certainly, but on both of the other ends also. Negative 10 divided by 2 is negative 5, less than or equal to x, less than 4 divided by 2 is 2. Now again, we have the x in between those 2 bounds, which we hopefully understand now means it's going to be a graph that comes together, connects the dots. Let's see. I got negative 5 on the left because it's smaller than positive 2. Negative 5 has the less than or equal to, so it's a solid dot. Now be careful, even though it says less than or equal to, what it's telling you is negative 5 is less than all the good answers for x. Well, if negative 5 is less than all the good answers for x, all the good answers are above it. They're on the right. It's going to move to the right. On the other side, x is less than 2. Open dot to the left. That's why they connect. Don't make arrowheads on this one. It's an and problem. It's an intersection problem. Values have to be between -5 and +2, but they can't be lower than -5, and they can't be higher than +2. So there's no arrowheads there. And that's the answer for number 7. Number 8, similar, 2 is less than 3x plus 8, which is less than 17. Real similar to number 7 in the work we have to do. Again, I got to get x by itself. I want to remove that plus 8. The best way to do that is to subtract 8. Again, that's the opposite operation. It's the inverse. So we're going to subtract 8 from where? Here, but also there, and also there. Careful with negatives. 2 minus 8 is -6. Less than 3x. Less than 17 minus 8 is 9. And now again, I have 3x, but I don't want 3x, so I have to divide everything by 3. Dividing by 3 cancels out the coefficient, but we have to do it on the other two sides also. -6 divided by 3 is -2, less than x, less than 9 divided by 3 is 3. We make our number line, or we use the one given to us. Less than on both of these is open dots on both of these. You already know that when x is between those two values, it will almost certainly come together in the middle. If you're not sure, this says x is less than 3, so it definitely goes to the left. This says -2 is less than x, and if -2 is less than x, x is more. See how x is next to the open part here? That means x is bigger than -2. It connects the two dots. The last question was tricky because of the way it gets graphed, but the way it gets solved is not that tricky. Let's take a look at number 9. The last problem we had to do. -2x minus 3 is less than 5, or 3x plus 1 is less than or equal to 16. All right, so we still have to solve the two problems one at a time. Over here, it says -2x minus 3, so I have to add 3 to both sides. No problems there. -2x is less than 8. I have to divide by -2. Now remember again, when you multiply or divide an inequality by a negative number, the symbol is going to reverse. So make sure you don't forget that. Dividing by -2 means I get x is greater than -4. Had to flip around because I divided by a negative. For the other one, I'm going to subtract 1 from both sides, and I get 3x is less than or equal to 15. Divide by 3, and x is less than or equal to 5. It's an OR problem. Usually that graphs as arrows pointing in opposite directions. Not always. And this is an example of what you have to be careful with. Here's my number line graph. I got -4 and I got +5. X is greater than -4, so it's an open dot. We know that ORs usually have arrows, so I'm just going to draw an arrow to the right. Now I know it's going to be going right over the 5, which is strange. We don't usually do that. But that's what it says the answer is, so we have to graph that. The other one says x is less than or equal to 5, so it's a closed dot on the 5, and it goes to the left. When it goes to the left, it also passes through this open dot, and it kind of fills it in on the way. So what does that mean the answer is? Well, the answer is everything. There's no number that won't work. Every number you could think of is greater than -4 or less than or equal to 5. Every single number fits that criteria. That was a tricky graph. You gotta be kind of careful with those. Now, what I'd like you to do is actually pretty easy. It's an IXL task, which I know from looking at the scores is not your favorite thing to do. What I mean by that is that many of you haven't done any of the IXL tasks, and unfortunately those are homework grades, which you can still do. You can always do them. You know the assignment, it's on Infinite Campus, just go do them. That was I.9, J. I think 3 or 8 or 7, whatever it is, it's there. Just go do it. Well, K.6 is actually just solving basic one-step inequalities. Basic one-step problems. That means that you'll either multiply, divide, add, or subtract only one time to get the answer. This is K.6. I'm looking for 90% success because they're pretty easy. If you got 100, you get extra credit. It's a homework assignment. I think the hardest problems they have, I mean, there's lots like this, which is hopefully not hard. All right, x minus 3. Okay, those are nice and easy. Maybe it'll be 4x. Maybe it'll be negative 3x. This is the hardest one I think that you might have. We'll use a different variable. They don't always use x, so I'm using a c right now. Also because I recall seeing them using c's there. So let's just do these real quick, all right? What would you do for this problem? Well, hopefully you recognize you would subtract 1 from both sides. So if I subtract 1 from both sides, x is greater than 8. And we'd be done with that problem. How about over here? I add 3 to both sides. X is less than or equal to 9. Pretty easy, right? How about this one? I divide both sides by 4, and x is greater than 3. How about this one? Well, here's a trick again. There's a negative value. I divide by negative 3, which is going to flip my symbol. And 9 divided by negative 3 is negative 3. This one is probably the hardest one you'd have to do. All we do to clear a fraction is multiply both sides by the denominator. This is a negative 2. I'm going to multiply both sides by negative 2. It's going to clear my fraction, so c is by itself. It's going to flip the symbol because it's a negative number I'm multiplying by, and negative 2 times 8 is negative 16. Those might be the hardest ones you have to do. But again, the strategy is just multiply by the denominator on both sides. If it was negative, flip the symbol around. That's all I'm asking you to do, so please start that now, and once you're done with it, you're done for the weekend, and I will next talk to you on Tuesday because Monday is a holiday. So have a great weekend. Please get it done.